Good morning. From today, we will begin our second semester portions, the core paper Mechanics and Properties of Matter. As I already said, in that paper, I will be teaching you Module 1, which is about wave motions and oscillations, and also I will teach Module 2, which is about rotational mechanics. Okay, so first of all, we will begin with Module 1, the first part of Module 1, which is about wave motion. Okay, so I have already posted the textbook that you have to follow for module 1 and 2. So for that I will upload a copy of that textbook. So that is the wave motion, the first part of module 1, wave motion, as PDF in your LMS, and from that uploaded PDF I will take classes one by one. Okay, hope it is clear. So in today's session, this is just an introductory class about wave motion. It deals with some basic definitions like what is meant by wave motion, what are the various types of waves that you know, then what is meant by wavelength, what is frequency, what is time period, and so on. Okay. So first of all, let us begin with the definition for wave motion. What is meant by wave motion? So here comes the definition. It is nothing but energy which is transported from one point to another in a medium. So that is called wave motion. Now you can have various types of waves like water waves, sound waves, electromagnetic waves, etc. So please note that water waves and sound waves, they actually require a medium for their propagation or for their travel. So they are called mechanical waves, whereas electromagnetic waves do not require such a medium for its propagation. It can propagate through free space. You all know about that. So here we got a definition, what is wave motion and what are the various types of waves that you know. Okay, then let us see how a wave originates. A wave originates from a source, that is there should for something to originate, definitely there should be a source. So similarly, a wave also originate from a source, which can be a source of disturbance, and once it originates, it will travel or it will propagate through the medium. How? By the repeated periodic motion of its particle about their equilibrium position. That is how the wave propagates through the medium, that is assisted by the repeated periodic motion of its particles about their equilibrium position, and each particle will repeat the motion of its uh, uh, predecessor. That is what the earlier particle does. Same thing will be repeated by the next particle. That is how the wave propagation takes place. So definitely there will be a phase difference, or there will be a fixed phase difference between the displacement of the particles. Now, depending upon the direction of displacement of the particle with respect to the wave, with respect to the direction of wave propagation, we can have two types of waves. One is transverse wave and the other is longitudinal wave. So a wave propagates from a source, then it will propagate through the medium by the repeated periodic motion of its particle about their equilibrium position, and depending upon the direction of displacement of the particle with respect to the direction of wave propagation, waves are classified into two, which are the transverse and longitudinal waves. Now here we will learn about what is meant. This is an important slide. You will get a question like distinguish between longitudinal wave and transverse wave with the example. Okay, so look at here. Hope you have studied all about this in your 12th standard. So just compare these two waves and study. So first of all, let us see how a transverse wave propagate. A transverse wave propagates at right angles, that is the displacement of particles in the case of a transverse wave is at right angles to the direction of propagation. Okay, but whereas in longitudinal wave, the particles of the medium vibrate to and fro about their equilibrium position along the direction of propagation of wave. That is, in the case of transverse wave, particles vibrate perpendicular to the direction of wave propagation, whereas in longitudinal wave, particles vibrate parallel to the direction of wave propagation. Okay, then next difference. Transverse wave is always described in terms of crest and trough, whereas longitudinal wave is always described in terms of compressions and rarefactions. Then transverse wave propagate only through those medium that is having a rigidity modulus, whereas longitudinal wave travels only along a medium that is having bulk modulus. Now this rigidity modulus and bulk modulus, they are all some properties related to elasticity, which you will study under module 3. Okay, now transverse wave can take place or it can occur only in solids and liquids, okay, not in gases, whereas longitudinal waves can pass or it can propagate through solid, liquid and gas. Okay, so these are the differences. So just compare these two and study. Now example for longitudinal wave is sound waves. Now example for transverse wave is light. Then okay, now here comes another definition. What is meant by wavefront and what are the various types of wavefront? Now wavefront means it is a plane or surface in which all particles of the medium are in the same state of motion at a particular instant of time. So that is called wavefront. It is a surface or it is a plane in which all particles of the medium will have the same state of motion at a particular instant of time. Now any line that is drawn normal to the wavefront is called as a ray. This ray gives the direction of wave propagation. Okay, so you got two definitions, wavefront and ray. Now there are three types of wavefront. One is spherical, then the other one is cylindrical, and the other one is plane. Okay, now waves originating from point sources are called spherical wavefronts. Now waves originating from line sources are called cylindrical wavefronts. And finally, the waves originating from sources at large distances are called plane wavefront. Okay. So these are the definitions that you got. What is meant by wavefront, what is meant by array, what are the various types of wavefronts, spherical, cylindrical and plane, and how does they originate. That is, waves originating from point sources generate a spherical wavefront, waves originating from line sources generate cylindrical wavefront, and waves originating from sources at large distances generate plane wavefront. Hope that too is clear. Now some basic definitions. What is meant by wavelength? Here they have defined wavelength for longitudinal wave and for transverse wave. Now in the case of a transverse wave, we define wavelength lambda as distance between nearest crest or nearest trough. Why is it so? Because in transverse wave is always described in terms of crest and trough. That is why in the case of transverse wave we define wavelength as distance between nearest crest or nearest trough. Now similarly in the case of longitudinal wave, how will you define wavelength? It is defined as distance between nearest compressions or nearest rarefactions. Okay, that is very clear from this figure. Now what is meant by time period? You all know that it is a time taken by the particle in a medium to complete one periodic motion. We can also define it as the time taken by the wave to travel a distance of one wavelength. Now what is meant by frequency? It is a number of waves produced by a source per second. Frequency is the inverse of time period. That is, we all write frequency is equal to 1 by t. Reciprocal of time period is frequency. So again two definitions. What is time period? What is frequency? Then what is meant by phase? That is state of vibration is referred to as phase phi. Now here comes the general definition for wavelength. So when you are asked to define wavelength, you can write this. That is, a wavelength is nothing but distance between two successive particles of the medium which are in the same phase of vibration. Okay, distance between two successive particles of the medium which are in the same phase of vibration. Okay, that is called wavelength. Then you can write, in the case of longitudinal wave, wavelength is defined as the distance between two compressions or rarefactions. That I will show you this one. In the case of longitudinal wave, wavelength is defined as the distance between nearest compressions or nearest rarefactions. In the case of transverse wave, distance is defined as the distance between nearest crest or nearest trough. That also you can write after writing the definition, this definition. Okay. Now, what is meant by angular frequency omega? It is rate of change of phase with the time. Then that is, what is angular frequency omega? It is the rate of change of phase with the time. Then what is meant by wave number k? It is the rate of change of phase with the distance. Okay, now here there is an important relation between the wave number k and wavelength lambda. It is k is equal to 2 pi by lambda. Now, what is meant by wave velocity or phase velocity? It is the velocity with which a wave advances, that is, a wave propagates through a medium. It is denoted by the letter v, that is given by nu lambda. Now, another important question: derive the differential equation of wave motion. So, for that, you have to consider a one-dimensional wave traveling along x direction. For that, you have to consider a source of disturbance. For the wave to originate, I have already told you that there should be a source. So we are imagining, or we are considering, a source of disturbance which is kept at a point O as shown in the figure. Now suppose that at a particular instant of time t, let the displacement of the particle at the origin be represented as y is equal to f of t. That is, y is the displacement of particle. It is represented as a function of time t. So y is equal to f of t. That is equation number 3. Now suppose that the wave reaches a point P which is at a distance x from O after a time t equal to x by v. Time is equal to distance by velocity, that is x by v, where v is the wave velocity. Now suppose if the wave is propagating along positive x direction, then equation 3 will reduce to y is equal to f of t. It reduces to y is equal to f of t minus x by v. That is, we are going to subtract this time from the equation 3. This is in the case of a wave propagating along positive x direction. Now, if you are considering the wave is propagating along negative x direction, then what happens to equation 4? You will have to write x by v will become minus x by v. So, finally, the equation becomes y is equal to f of t minus of x of v. So, minus and minus get plus. So, this equation actually stands for a wave propagating along positive x direction, and this is in the case of a wave propagating along negative x direction. Now, so combining these two, that is combining equation 4 and equation 5, we can express the general form of wave traveling in x direction, that is f y is equal to f of t minus x by v plus f is equal to t plus x by v. Here this component stands for wave propagating along positive x direction, and this stands for wave propagating along negative x direction. So combining these two, we write the general form of wave traveling in x direction. Now our equation 4, we have to differentiate it with respect to x. What is your equation 4? Y is equal to f of t minus x by v. So differentiating with respect to x, dy by dx equal to f dash of t minus x by v into minus 1 by v. Okay, then again d square y by dx square will be equal to f double dash of t minus x by v. What is the differential of minus 1 by v? It will be minus of minus 1 by v square. Negative will become positive. So the final answer will be d square y by dx square is equal to 1 by v square f double dash of t minus x by v. See, that is given in equation 8. This is simple differentiation, so you can work it out. Now that is given in equation 7. Okay, equation 7 what I wrote. So you can work it out. It's simple the differentiation, and then So equation 4 you have now differentiated it with respect to x. Now the same equation, that is equation 4, you have to differentiate it with respect to t also. That you will have to do it yourself. Okay, so f double dash, you know, it represents second differential. Okay, if we put f dash, it is first differential. If it is f double dash, it represents second differential. That is f dash means dy by dx, f double dash means d square y by dx square. Hope all that is you have learned in your lower classes. Okay, so we have got equation 7 and 8. Now just compare equations 7 and 8. Here or this one is the same, right? This part is same and this part is same. So here you can say that what is left is d square y by dx square is equal to 1 by v square. Here you have d square y by dt square. So on comparing, we can comparing equation 7 and 8, we can write d square y by dt square is equal to v square d square y by dx square. Okay, so this is the most important equation, or it is the differential equation for one dimensional wave traveling along positive x direction. See the equation 9, that's an important result. Here this d square y by dx square, it represents curvature of displacement, whereas d square y by dt square represents acceleration of particle, okay, at a particular point. So this equation, or the wave equation, it suggests that particle acceleration is nothing but product of square of velocity, that is v square. So product of square of wave velocity and curvature of displacement curve, that is d square y by dx square. Okay, for today this is enough. Now so here what all things you have to learn, I will just brief once again. What is wave motion? How does a wave originate? Distinguish between longitudinal wave and transverse wave with example. What is meant by wavefront? What are the various types of wavefront? Explain. That means you have to say which all, how the cylindrical, spherical and plane wavefront originate. Okay. Then what is meant by array? Then what is meant by wavelength? So first of all, you have to give this general definition for wavelength and then come to this one. Okay. Then what is meant by time period? What is frequency? What is phase? What is angular frequency? What is wave number? So when you are asked wave number, you have to write this equation 1 also. Okay. Then define wave velocity or phase velocity. Then this is most probably a 5-mark question, that is derive the differential equation of wave motion. So these are the important questions that are likely to be asked from today's portion. Okay. So that is enough. Thank you.